Okay. Hello. Hope you guys are doing well. So I want to go over questions 6, 7, and 8. I'm probably not going to do all of those questions, but I do want to get you set up for those questions. So on one page, I'm going to have the formulas that we're going to use for each question, and then the other page will work the problem, okay? So first off, question 6 says to evaluate sine theta, cosine theta, and tangent theta of the following right triangle. Right triangle is here, 6, 10. Now, before we go off into what is sine theta, cosine theta, and tangent theta, there is something missing slightly from your review here that will be on your exam, and that would be where the question of where theta is, and it have to be in this corner here. It doesn't have to be, it could be this corner here, but I'm going to say make it this corner. I believe that's the way it's marked on your exam. So that theta, this would be this side, and that changes the orientation of the triangle. Remember, you're identifying where the opposite side is, the hypotenuse, and the adjacent side. So you have to know where the angle is. So what we're saying is that this angle here is theta. That's the one in question for these three trig functions. But for now, how to find right triangle trig. Trig. There are a few formulas that we need to remember. First is a squared plus b squared equals c squared to solve for the sides of the triangle. C has to be the hypotenuse. And then we have 6 trig functions. The first one is sine theta, which is opposite over hypotenuse. Remember, the reciprocal of sine is cosecant, so cosecant theta is hypotenuse over the opposite side. Then we have cosine theta, which is adjacent over hypotenuse. And I already go ahead and I would say let's look at secant theta, which is hypotenuse over adjacent. Reminder, the reciprocal functions, you are just flipping the fraction of cosine for secant. Now we have cotangent and cotangent. Tangent of theta is opposite over adjacent. So cotangent theta must be adjacent over opposite. Okay, so those are going to be the trig functions that I would put on your index card. These 6 are really important to know, and they're very commonly used with triangles, right triangles anyway. But these 6, and then the ones that say that sine is y, cosine is x, tangent is y over x, those ones that we went over in class the other day, those are also important to know. So we're going to reference back to this in a minute. But to evaluate sine, cosine, and tangent of the following right triangle, the first thing that we need to identify is what side is opposite, what side is the hypotenuse, what side is adjacent. So always the hypotenuse is across from the right angle, so this must be the hypotenuse. Directly across from the angle in question is side opposite, and this must be the adjacent side. Now the problem with the adjacent side is we are missing a value. That's where we're going to use a squared plus b squared equals c squared to identify. So if I do that, a squared plus b squared equals c squared, that's going to be, this can be a, so we're going to say a squared plus 6 squared equals 10 squared. Remember, c is always 10 because it's the longest side. This becomes a squared plus 36 equals 100. And then a common mistake here is to get 136, but you do have to subtract 36 from both sides. So it becomes a squared equals 64. And then a is equal to 8 if I take the square root. So this side here is 8. okay? So now I have all three sides. That's the first step. The third step is to evaluate. We know sine of theta from our list here. Sine of theta is opposite over hypotenuse. So opposite over hypotenuse. The opposite side is 6. The hypotenuse is 10. 6 over 10 can be reduced. If we reduce both of them by 2, we get 3 and 5. So our final fraction, our final ratio is 3/5 for sine. And that's kind of what you're going to want to do with all of them. You're going to want to place the ratio, reduce, and then you'll have your answer. So let's look at cosine. Cosine of theta is the adjacent over the hypotenuse. The adjacent side is 8. The hypotenuse is 10. Once again, both can be reduced by a factor of 2. So if I reduce 8 by 2, I get 4. 10 by 2, I get 5. My final ratio is 4/5. And then lastly, we're looking at tangent. Tangent of theta is the opposite side over the adjacent side. So my opposite is 6. My adjacent is 8. We reduce 6 over 8 by 2. I get 3 and 4. So the final ratio is 3/4. And then those are the three answers for evaluating sine, cosine, and tangent of the following right triangle. So that would complete number 6. If we look at hold on, let's see if I can move this up a little bit more. Okay. If we're looking at number 7, it says determine the 5 trig ratios of theta that satisfy the given conditions. So the first, number 6, the difference between 6 and 7 is that 6 does not give you conditions. The condition here is that tangent of theta, they gave you a ratio. And then that also tells you if tangent is positive or negative. That's really important, because if tangent is a different value, if it's a different sign, if it's not positive, then it could be in a different quadrant. This one up here, it didn't matter because they gave you the triangle and you're going to assume all were positive. But because they are now giving us a condition, we have to check what quadrant we're in. So as a quick reminder, quadrants, you have both coordinates are positive in quadrant 1, x is negative in quadrant 2, both are negative in quadrant 3, and y is negative in quadrant 4. Now, if we remember, sine of theta is the y value. So when it says y is greater than 0, you're saying that y is positive. Well, what quadrants here is y positive? That's the question you need to ask yourself. You notice here that y is positive in quadrant 1 and in quadrant 2. So for this one, it's in quadrant 1 or in quadrant 2. Oops, my bad. So tangent is different though. Tangent is not y, it's y divided by x. And what we're saying is y divided by x is 9 over 4. But the sign here is positive 9 over 4. It's not negative. It would say negative if it was negative, okay? So because y over x is positive, think about dividing numbers. How would you get a positive? You would divide by either 2 positives or 2 negatives. So if I'm dividing by 2 positives to get a positive, so this is also greater than 0, I would need the first to be positive over a positive, or I can divide a negative over a negative. Those would both give me a positive. Where does that happen? Well, we're looking for where we have the same sign. Positive, positive, negative, negative. We're in quadrants 1 or quadrant 3. Now, we know we're in quadrant 1 or we're in quadrant 3. So here's what I would say. Compare the two. If tangent is positive and sine has to be positive, that means they both have in common quadrant 1. So that's where the triangle lies. That can be kind of tricky to determine, so you guys really need to make sure that you are really focusing in on what's positive, what's negative. Maybe write this on your note card so that you can kind of figure it out. And you also will have those ratios of like tangent is y over x, sine is equal to y, so you can kind of tell what's positive, what's negative. I usually like to draw my triangle in the quadrant that we're in. So if we're in quadrant 1, can't be quadrant 2 or 3 because they don't have anything in common for these two functions. So quadrant 1 is here. That's the right triangle that we're drawing. This is the coordinate in question. How do we get to that? We would take the opposite and the hypotenuse and everything to kind of figure out this triangle. So how this works is this is the angle in question, that's theta for this, and it's always going to be the reference angle, which is what this angle is. So what's the opposite side of this? It's here. What's the adjacent side? That's there, and the hypotenuse. Now we just need to fill in values, but they already gave you values. So as a reminder, tangent of theta, if we refer back to our formula sheet, tangent of theta is opposite over adjacent. So the opposite side is 9. The adjacent side is 4. So this is going to equal 9. This is going to equal 4. Now we need to determine the hypotenuse. That's going to be a squared plus b squared equals c squared, which is 9 squared plus 4 squared equals c squared. That's 81 plus 16 equals c squared. That would be 97 equals c, and c squared. And then the square root of 97 is c. So you're going to get a really large square root. That's okay if you got this already. Don't panic. Can't be simplified, so we're just going to leave it as the square root of 97. So that's a lot of work in this problem, but we're not even started yet. We still have to evaluate the 5 remaining trig functions. The 5 remaining trig functions, we already have tangent. Tangent is 9 over 4. We want sine, cosine, cosecant, secant, and cotangent now. So we're going to use these formulas again to evaluate the this triangle here. So if we do that, I'm trying to move this down a little bit. There we go. We have tangent. Let's look at sine. Sine of theta is the opposite over the hypotenuse. In this triangle, opposite is 9. Hypotenuse is the square root of 97. I get 9 over the square root of 97. Don't forget you must rationalize anything where the square root is in the denominator. So if I rationalize by multiplying by the square root of 97, yes, it's going to look very weird. Yes, that's okay. So this becomes 9 times the square root of 97 over 97, and that is my answer for sine. Cosecant is what I always do right after sine, because cosecant is the reciprocal. It's hypotenuse over the opposite side. The hypotenuse is square root of 97, and the opposite is 9. And that's done. There's no simplifying that can be done here. So 2 answers. I need 3 more. We're going to look at cosine, which is adjacent over hypotenuse. Adjacent is 4. Hypotenuse is square root of 97. So this is 4 over the square root of 97. And now we need to rationalize. multiply across, I get 4 square root of 97 over, this becomes 97. And we're done with that one. I have 2 more. So now I would go on to secant. Secant is the reciprocal of cosine, or we can just say it's a hypotenuse over the adjacent. Hypotenuse being the square root of 97, adjacent being 4. No simplifying can be done. That's our answer. Okay. And then lastly, we're looking at cotangent. We have tangent. Cotangent is the reciprocal of tangent, so that's going to be the adjacent side over the opposite side. The adjacent side is 4, opposite is 9, so this one is going to be 4 over 9, and that's my final answer. So these are the 5 answers I'm looking for. Okay, as simplified as you can get them, that would be 5 points on this exam. Okay, please don't think of this question as like a loss because it has a lot to do with it. You don't want to do that, because if you can see on your review, it's worth 10 points, and that is true. It's going to stay worth 10 points. Part A will be worth 5, and Part B will be worth 5. If you make a mistake here, it is going to mess up the whole problem. So make sure you don't make a mistake here. You can't simplify the square root here, just write it out. If you can simplify the square root, simplify it, but that's not the case in this one. Okay, I do want to set up the second one for you, just so that you can see the quadrant that we're in, and I'm not going to solve it. You guys can do that at home. Okay, so the difference with this one is that this is cosine of theta is -1 over 3, and tangent of theta is less than 0. So we still have this, let me move this back, we still have this visible, so we're going to use this as a reference. Cosine theta is negative. Cosine is the x value. If it's negative, that means it's less than 0. So we have x being negative, right? Where is x negative? That's what you need to ask yourself. X is negative in the second quadrant and in the third quadrant. So this is going to happen in quadrant 3 and quadrant 4. Tangent is negative. Tangent is y divided by x, so that's less than 0. So when you're dividing functions, instead of having the same sign, they have to have different signs. So now you're looking for where we have different signs, and that's going to be in quadrants 2 and in quadrant 4. So it's pretty obvious, both of them have in common quadrant 4. So quadrant 4 is going to be where this triangle lies. And like I said, I draw it in that quadrant. So in quadrant 4, we have a triangle with a right angle. The reference angle is the angle in question. The opposite side would be here for this triangle, the adjacent side here, and the hypotenuse is here. So now when we're looking at cosine, we know cosine is the adjacent side over the hypotenuse. So the adjacent side is 1, the hypotenuse is 3. The hypotenuse is 3, the adjacent is 1. Something's wrong here. What did I do wrong? Oh, I'm an idiot. I tried to get this set up for you guys and I messed it up. Look at me. I even said it, I thought, that quadrants 2 and quadrant 4, and this is why I love and hate doing this on a computer, because you guys aren't there to like call me out on my mistakes. So it is what it is. It happened. We move on. Let's move back to this. We know that this is correct because it is, in order to get tangent to be negative, has to be opposite signs. But I said x has to be negative here. And I said it, I know I said it, x is negative in quadrant 2 and in quadrant 3. So we had, this should have been quadrant 2 here. meaning that quadrant 4 is not what's in common, but quadrant 2 being in common. That's why it wasn't making sense to me, because this is a positive x, not a negative x, and the negative has to be the 1. Okay, negative has to be 1 because the hypotenuse is the distance from the center to the edge of the circle. It's never going to be negative. So if we redraw this, excuse my mistake here, I apologize, it should be here, and this should be now opposite. This is the hypotenuse and this is the adjacent. And when you're placing what you know, you want the -1 to be here and you want 3 to be here. So you need to find the opposite side, and then you go along with the triangle as you normal as the rest of it. Okay, so I apologize, my mistake, but that's how you're going to set this up. Hopefully I didn't confuse you more. Personally, I don't want to start this whole video over again, so we're just going to leave it as that. Oh well, it is what it is. I need more paper. Okay. There we go. All right. So moving on to question number, I'm trying to make this a quick video. I don't think I could ever get under 30 minutes on a teaching session, but it is what it is. So trying to get moving on to the reference angles. I do want to cover real quickly what reference angles are, because it has been a minute since we went over them in class. Reference angles is a reference angle is formed with the terminal side and the x-axis, and it's the acute angle. So it's the acute angle formed with the terminal side and the x-axis. So there's a couple of different angles that we're talking about. So when we're in standard position, we're talking about we go from the x-axis to the terminal side. This would be the terminal side. So here's the angle that we're talking about, that's theta. The reference angle is the acute angle formed by the terminal side and the x-axis. So that's the acute angle formed by the terminal side and the x-axis. Your rules are going to change depending on the quadrant that you're in. So, sorry, I'm going to write it up here. If we're in quadrant 1, our reference angle is actually the same thing as our angle. They're equal to each other. So the formula here is that your reference angle equals your angle. Okay? Now, like I said, it's going to change depending on what quadrant we're in. So let's look and see what happens when we're in quadrant 2. When we're in quadrant 2, that's the terminal side. This is the angle that goes from the initial to the terminal. That's our angle that's given to us. Okay? The reference angle is going to be from the terminal to the x-axis. That creates that acute angle. And in this one, it looks like this. So how do we find that? We're going to take, 180 degrees, and we're going to subtract our angle. Or we're going to take pi and subtract our angle, depending on what we have, radians or degrees. So this is 180 degrees here, this straight line here. So we're going to take that, subtract this, we'll be left with this. Quadrant 3. Quadrant 3. So if we're in quadrant 3, that's going to be here. Remember, our angle goes from the initial to the terminal. That's theta. That's the given angle. That's what you'll be given. And the reference angle is formed with the terminal side and the x-axis. So this is the reference angle. So how do I find this? Well, my reference angle is going to be bigger than 180. So I'm going to take my reference angle or my angle given, right? My angle is going to be bigger than 180. I'm going to take my angle and subtract 180. Or I'm going to take my angle and subtract pi. Whichever one units you're in. Okay, so that's quadrant 3. So you have quadrant 1, 2, 3, and last is quadrant 4. So for this one, quadrant 4 is here. Okay, this is the initial side. This goes to the terminal side. This is theta. That's our given angle is in green. The reference angle is formed by the terminal side to the x-axis, the acute angle. So that's going to be here. It's like the completion of the full circle, but it's this one. So since we're working with the completion of the full circle, we're working with 360 degrees for my formula. I'm going to take 360 and subtract the angle that I'm given, not the reference angle. That'll find me my reference angle. And if I'm working in radians, we're going to take 2 pi and subtract theta. And then that's it for all 4 quadrants. I would put these on your index card. I'm not going to be writing anything on the board. You will be given the unit circle, but you will not be given these formulas. So, and also, I just want to point out that question 8 also says to sketch the graph in standard position. These are the sketches of the graph. I mean, that's it. If you're in quadrant 4, it's going to look something like this. I mean, it might be a little closer here, it might be a little closer here. You can estimate that if you want. It doesn't matter to me as long as you're in the correct quadrant. That's what I'm looking for. So if you're in quadrant 2, it's going to look like this. You're going to want to sketch both, the angle and the reference angle. Okay, so bring color, pencil, paper, whatever. Not paper, but you know what I mean. Colored pencils. So if we're looking at our problem, I was going to do part B. So our angle for part B is 6 pi over 5. Now, a lot of you have been questioning 6 pi over 5, what quadrant that's in. I've gotten so many of those questions in the past couple of days. So one thing that you can do is take 6 pi over 5 and convert it to degrees very quickly. You're not going to want to leave it in degrees. You're going to want to work it in radians. But if I were to convert this to degrees quickly, right? So 6 pi over 5 times 180 over pi, right? If we convert this to degrees, I'm going to get 6 times 180 divided by 5. This is 216 degrees. Okay? So 216 degrees is in what quadrant? That's what you need to say to yourself. 216 degrees is greater than 180, so it's in quadrant 3. So this is 216 degrees, or this is 6 pi over 5. Okay? So that's like an easy way to determine where this angle lies. Now I can do all the math in radians. So I'm in quadrant 3. My formula for quadrant 3 says that this is the reference angle, and I'm going to take theta, my angle, and subtract pi. So theta, my angle, which is 6 pi over 5, and subtract pi. That'll give me the reference angle, and the reference angle is here. Okay, so that's the point for drawing it. This one would be 6 pi over 5 minus, I have to have common denominators, so it becomes 5 pi over 5, and I subtract. 6 minus 5 is pi over 5. Please, 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 when you are working this, please make sure that you are leaving your answers in radians. If you're going to convert to degrees to figure out where your angle lies, that's fine, but you need to make sure if you're given radians, you need to leave the answer in radians, and that's it. Okay, so I hope this helps. I'm really proud of myself because I just noticed it's just under 30 minutes. Literally, I'm gonna finish at the 30-minute mark. I hope this really helps. I really do. Please let me know if you have any questions. You guys can do A. I know you can do A. You have all the formulas for everything. Please write your note card before class on Monday because you're not going to have time on Monday. Okay? Hope you have a wonderful weekend. I'm signing off now, and goodbye.